Hello, everyone. Welcome to the PlayStation VR talk. My name is Madhavan, and I'm a technical account manager at the PlayStation's Developer Technology Group. And my job there is to work closely with the engineering and the production teams of various game studio partners we have, small, medium, or big, and ultimately to help them realize their goals on the PlayStation platform, and along the way make things easier for them in the development and the submission process. So almost a year ago, last October, we launched PlayStation VR headsets, and it continues to be very well received by people across the world. Thanks to great content and also the high quality VR experience it offers. So in this presentation, we hope that we'll provide you with a high-level checklist of sorts, where with people who are interested in becoming a PlayStation developer, or those who are new developers can learn some best practices which can make your lives easier during the PlayStation development. So here are the things we'll cover today. So we'll take a look at some recent business numbers related to PSVR, provide a high-level overview of the sign-up and development process, and we'll quickly look at some Unity PSVR integration point, so you get an idea of how the build settings would look like when you're working with PSVR. And in the last section, we'll look at the VR consultation process, so what it is, and share some key lessons that we learned through all these submissions that came along for 1 year of PSVR. So hopefully those tips and best practices will save you time as well. So first, let's take a look at some numbers. So as of June this year, we have sold over 1 million units of PSVR across 64 countries and regions worldwide. We have over 100 PSVR titles already published and 220 in development, and many of them are made with Unity. And this number is pretty old, so I'm pretty sure the numbers are much higher. So we also received an update that PSVR titles have sold over 10 million units in total as of September 22nd. So we'd like to really thank our developers and the consumers who have made this launch like a big success, and also for the tremendous reception that it was received. So before moving on, I just want to do a quick poll. Please raise your hand if you're a PlayStation licensed developer already. Okay, good. I would say about good 10 to 15%. So for those who are already registered, you might have gone through some of the steps already, but hopefully some of the items in this section might help you as well in the current stage of development you're in. So if you're interested, the first step in this process is getting licensed. In getting licensed is to visit that URL and fill out an online application. And once you're licensed, you'll be assigned an account manager who will be your main point of contact inside PlayStation. Yeah, I just want to note that the process of assigning an account manager is slightly different in different regions. Next step would be to get access to a variety of internal portals, and the key ones being DevNet and TPRNet. So DevNet is a dedicated go-to place for development. Like, it has documentation, tools, performance analysis tools, configuring network services, and support channels you get from the engineers. Oops. Well, also about the TPRNet, well, that's a go-to place for managing digital and physical products. In addition to that, it contains some best practices, documentation, and submission planning tools, which you should definitely try it out, because it helps you estimate how much time it's going to take depending on your title. Next step would be to get your hardware. So please note that you need PS4 Pro dev kits and PSVR headsets for development. You must make sure to test your game both on PS4 and PS4 Pro test kits, as it is a requirement to support both versions of the hardware. Next step would be to download the PS4 SDK. So there is an SDK manager tool that can be downloaded on DevNet, and which can be used to download various revisions of SDKs, depending on what version of Unity you're using. There's also a lot of as mentioned, libraries, performance analysis tools, publishing tools, and so on. So just getting familiarized yourself about the whereabouts of the tools and where they're located would definitely go a long way in your development process. Next step is to get your copy of Unity Pro. So it's absolutely free of cost for PlayStation platforms, and additionally a suite of Unity plugins and samples, such as like a drop-in VR demo sample and a VR aim controller sample, and so on, is already there. I do want to note that if you're planning to use those plugins in your game, then it's your responsibility to make sure that you're compliant with the technical requirements of the platform. So as you know DevNet more, you'll get to know that there's a lot of stuff in there. The amount of resources, documentation, it could be a little overwhelming. So we have created a PSVR portal inside of DevNet so that it makes things easier for you to find things such as PSVR relevant documentation, samples, processes, best practice guides, and so on. So reviewing this portal should be one of the first things that you would have to do as a new developer. The next step would be to make sure that you use the support that is available on DevNet. So there is a dedicated Unity forum on DevNet for Unity PS4 related discussions. So you'll see Unity engineers jumping in and supporting you on Unity PS4 issues, which is awesome. And there's also DevNet forums, which can be used for having PS4 platform related discussions. And there's also a private support channel which can be used for discussing title-specific information if you have something sensitive like policy and whatnot. So don't hesitate to use it. It's there to help you out. And finally, not really a checklist item per se, but test your builds early and often on PSVR. So it's very easy to stick with one platform and iterating there, and then you'll get a surprise when you enter the next stage of your submission. So our suggestion is try to keep your generating builds and check it side by side. And I think that would definitely help you out quite a lot and make your lives easier. So all right, so that was basically a wrap of a very high-level checklist for developers. So remember that if you're stuck anywhere, feel free to reach out to your account manager or ask on DevNet, and I'm sure you'd get some help there. So in the next session, we'll look at some settings and options that are available to you in the Unity build settings. So let's start off by turning on the VR mode. So first step would be to locate the virtual reality supported checkbox item and check it. It's pretty similar to all the other platforms. The next step would be to set your game's refresh rate target. So for that, you have to find the VR reprojection rate and choose one of the values in the drop-down menu. So whatever value you choose would be your frame rate target as well. So we will talk about reprojection a bit more in a few slides, but just at a higher level, reprojection is essentially the process of distorting or displacing the previously rendered frames based on the predicted head movement so that it appears approximately where the specified frame would appear in a specified time. And that time is specified based on the reprojection rate that you choose. However, there is an exception to this, to these values. So if you choose 60 hertz, it means you'll be rendering at 60 hertz and reprojecting at 120 hertz on the headset. Whereas for 90 hertz and 120, it will match the values that you choose. For example, you'll be rendering at 90 and reprojecting at 90 hertz. And for 120, it's the same. So next, there are two options for stereo rendering method. So at a high level, in single pass, both eyes are rendered at the same time, rather than rendering left eye and then right eye separately, like you do in a multi-pass rendering. So choosing single pass method usually gives you back a significant amount of time on the main thread, and also reduces the rendering time on the rendered thread. However, certain screen space effects might need to be adjusted to work as you expect. The next item is graphics jobs mode, which allows you to use either native or legacy mode. What mode you choose depends on your CPU performance profile. So use native if your game is render thread bound on the legacy mode. So the more heavily you're render thread bound, the more likely you will see the performance gain while choosing this mode. So legacy mode is good default options to start with if you're just basically main thread bound. So this feature is still marked experimental, so if you find any issues, please report back to us. Next is setting the IPD, which is interpupillary distance, essentially the distance between the pupils. So there are two values to use from in your games. One is the IPD value that was set by the user, which is set by measuring it using a tool on the PS4. And the other one is system's default value. So if your game has modes such as having to pass the headset across to different players, then there is another third option which will come handy, which is which selecting that allows you to change the values from a user mode to a system default mode and vice versa. So there's some good documentation available on the Unity help. So I would highly recommend looking for the third mode on the Unity documentation, and you will find information on the API that you can call to change between that. Next is really quickly audio settings. So choosing the PSVR audio out 3D will enable the spatial audio that can be heard by the regular headphones connected to the PSVR headset. It also enables the virtual speakers drop-down option that lets you choose the number of 3D audio, number of virtual speakers, and you can set the 3D audio position around your headset. So that was a really quick look at some important PSVR integration points. So you can find the Unity PS4 documentation under the help once you install the PS4 add-on. So I highly recommend investing some time in there before you start your development process or porting process. So in the next section, we'll see what VR consultation process is and share some lessons learned that should be kept in mind during your entire development and testing process. So VR consultation, or shortly VRC, is an important step in your PSVR development process. So it is a mandatory step involving technical evaluation to improve the overall PSVR experience. So you have to pass the VRC to enter the submission. So the earlier you plan and submit, the better it is. So if, let's say, your build is in a state which is representative of your final build, we recommend that you enter VRC as soon as possible so that the feedback that you get and the issues that are reported back can be implemented, and you have time to do that. And just want to note again that this is in addition to the submission process itself, so that is something that you have to plan as well. So in addition to plenty of guides available on this topic on DevNet, there is also a sample called as a PSVR Comfort Sample. We highly recommend you to play around with it because it's a great tool to identify what a poor implementation looks like. For example, the sample provides a lot of knobs, such as reducing the frame rate, increasing the latency, and so on. And I think this is a good tool to train yourself to identify issues, and also for your testers, as you give them the builds, they should be aware of what kind of issues could arise. Now let's look at some most common issues that we see during the VR consultation process. So testing and knocking down these issues, I think it'll make your game experience much better and also minimize the number of times you have to go through VRC process. So let's start with reprojection issues. So there are two issues here with kind of a similar causes, so we'll go through both of them one after the other. So the first one is Hall of Mirrors, which appear during vertical or horizontal movement of the head, and it's commonly noticed around the loading time of your games. So let's take a quick look at how it looks like. So now so you can see the garbled Hall of Mirrors effects. All right. Let's take the next one, which is the reprojection errors. So I'll show you the good use case first. This is how it's supposed to look. Now let's take a look at the bad one. So just notice around the edges of the screen, you'll see some white kind of issues. So the first look, it's pretty hard to see, but when you slow down, you can see that white little edges. All right, so the common suspects for these issues are the frame rate drops and latency. So incorrect prediction time is also a cause. However, the prediction time itself is very well handled by the Unity implementation. So if you're still seeing this issue, which many developers seem to do, so here are the ways to avoid that. So ensure that you're in line with the VR reprojection rate that you set. That is, if you set 90 hertz, then try to meet that. Next is, since this issue is commonly seen around the loading screens, we suggest you to take a look at these alternate options, which is you can try using the cinematic mode for the loading screen only, or you can use just a black screen with audio going on in the background so that the player knows that the game is still loading. So these two approaches could kind of act as a workaround for the issue. The next commonly seen issue is double framing. So the issue is generally noticed as object ghosting or stutter effect that over prolonged use case cause eye strain for the user. So to understand the root cause of the issue, we wanted to go, let's take a look at the reprojection basics and then talk about the issue itself. So as discussed before, so reprojection essentially displaces a previously rendered frame to a location where the frame is expected to be at a specified time. And this is done based on the head prediction movement and the value that is set on the VR settings. So let's take a look at this. So assume that your head is turning to the left. So the reprojection system calculates a probable delta at the time offset. And as you can see, the image is shifted right. However, we won't have image data that lies beyond the bounds of the original frame because it's essentially displacing the previously rendered frame. So the question is, what do you do about this black edge? Well, you can just leave it black, or you can use a mirror filling. So it's a surprisingly effective alternative to kind of make it feel much smoother. Anyways, if you're wondering why we are talking about this, I just want to set the stage a bit for the next issue itself. So let's say you have a cursor in the middle of the screen. Well, when reprojection happens, the cursor is no longer at the center where it should be. So as a result, what happens is, let's say you're rendering at 60 hertz and then you're reprojecting at 120 hertz. Your cursor is essentially switching back and forth at 120 times a second, and that appears blurry. So let's take a look at how it looks like. So the video was captured at 120 hertz, so you can see that it appears a little blurry, but that's due to the persistence of the vision. But when it slows down, you can actually see the issue here. All right. So to summarize the causes, so high latency and insufficient frame rate is once again a suspect here. And also, as the example showed, use of full frame reprojection in the presence of, let's say, of object mounted onto a camera, such as cursors, or you have fast-moving cameras viewed through a cockpit-like environment. In that case, you will see jitters in your cockpit environment. Or you just have objects that move really fast. For example, cars passing by or spaceship going fast. So all those issues could cause this issue. So in Unity, you may consider using post-reprojection layer, which is a non-reprojected layer. So where you can add the items onto that layer if you don't want that to be reprojected. So the next one is quite straightforward. That is, aim for a higher frame rate because it's seldom seen in higher frame rate games. So let's look at image quality issues. So aliased or improper aliased rendering in your game is a potential trigger for simulator sickness. So, there really isn't a straightforward solution. So you may have to test your game with various anti-aliasing solutions provided by the Unity engine. So in our experience, we have found that MSAA seem to yield much better results than FXAA. We also recommend super sampling at 1.4 times the size of the buffer because due to the types of distortion, lens distortion happens in the behind the scenes, this seemed to give you the dot-to-dot rendering at the middle of the eye. You may use just simplistic super sample anti-aliasing also, but that's going to cost the traditional anti-aliasing costs. The next issue is kind of less technical and more of a choice of bright colors or choice of colors or brightness in your game. So drastically changing the brightness of the entire field of view, or just putting bright flashing objects could strain the eyes for the players. So we recommend using gradual changes in brightness and avoid overly bright images or effects on the screen. So for example, you finished loading and you're just about to show your logo, then we recommend that you gradually increase the brightness and then fade it off. And then once again, gradually increase the brightness in the game itself. So that seems to work quite well. So the next one is depth conflict issue. So what it means is in VR, rendering objects in an accurate depth order becomes more important, be it UI components or other 3D objects. So let's take a look at this example to illustrate the problem. So assuming you have a creature behind the tree, and ideally, viewing from the headsets, you would be seeing just a tree. However, sometimes you might want to give a cue to the user about the occluded object. So this is not recommended. However, if your game really needs to, then you can consider one of the following workarounds. So you can make the object shadow transparent or make the edges feathered, like that. Or you can use an unlit object so that it does not pop up in the face of the user, or just simply use an outline of the occluded object. All this works better than just a straight up shadowy image of the occluded object. So let's try to illustrate this issue with a UI component. So let's say you have a UI cursor, a UI component like a cursor or a text suggesting what to do. So there comes a problem of rendering like a hand or a tracking device in presence of those UI. So this is certainly in addition to the problem that we already discussed, which is the double framing issue, which you have to address anyways. But anyways, we actually suggest that you incorporate these UI elements in a more natural way inside the world itself. We feel that that's a much better way to render the UI. So to summarize, rendering objects out of order, especially far objects on top of the near objects, is problematic in VR. It may cause eye strain for your players on prolonged usage. So the suggestion here is to try to best maintain the order as it is. If not, try to use a much more softer effect of the occluded objects that you want to render. For UIs, consider rendering them as part of the game world itself instead of a separate, unnatural world. So the next issue we see here is the design of control scheme. So controlling the movement of the user in VR with an external controller is a bit tricky. So having a smooth and, let's say, continuous player movement like you would in a normal 2D game may cause the user discomfort and can cause triggers and can trigger simulator sickness. And the reason is the disassociation of the user's actual movement in presence of camera movement. So here are some solutions that we recommend. If possible, use snap turn movement with an instant viewpoint change. So if you're already doing that, but if you have like a blackout times between the viewpoint change, try to eliminate that, because we feel that the blackout kind of adds an additional discomfort to the users. Next session would be to consider supporting teleportation. However, adding the ability to perform finer movement would be even better. So if the above two is not possible, and you could try setting a tangential velocity and inertia to a more comfortable value based on extensive user testing. Or even better, you can let the user determine that at the start of the game before throwing the user into a very crucial battle scene. So you can let them choose the setting. So you can use one of them or all of them. It's up to you. So the next and the last one is like a list of other commonly seen issues. So I just want to really quickly go through these, starting with incorrect stereo. So incorrect stereo is essentially when the output buffer of the left eye and the right eye are not consistent. So if they're not the same, then it's going to cause, if they're not consistent, it might cause something called as a retinal rivalry for the player, and on prolonged usage, it's going to cause discomfort. So this is primarily caused by screen effects or applying different effects in different eyes or using different LODs for objects on different eyes and so on. So those things should be avoided. Next is OLED characteristics. It's always important to understand the OLED characteristics. Sometimes color leave the residue over other pixels during the head movement. And potential for triggering simulator sickness or prolonged usage. So the cause of this is the delay in the OLED emission due to the changes seen in primary colors, if you're using different colors, or brightness change. So I think you should keep this one in mind when choosing colors or brightness for various areas of your games, and test for this. So the next two are fairly straightforward. First is don't disable the player's head tracking, be it partially or fully or temporarily. The head tracking should always be mapped onto the game camera. Next is inappropriate initial position. So this was more of an annoying issue for the user. So if the user is unable to interact with the objects or read the text in the scene, then it might cause fatigue and they might just quit. So the cause of this issue is incorrect usage of the head tracking position in relation to your game's coordinate system. So the suggestion here would be to test the game assuming that the player is 1 to 2 meters away from the PlayStation camera, and make sure that the objects are reachable and the text is legible. And also finally, you should implement the long option button press to reset the initial position. So this is a technical requirement as well. So to wrap it up, PSVR offers a great opportunity for Unity VR developers to shine on the platform, where I think over 1 million user base is looking for more content and a variety of content that you can offer. To make things easier, we do have a Unity Pro license for free for PlayStation 4 and PlayStation VR development. And to have a smooth development experience, I think the key here is to get familiar with the VR consultation process, the various issues seen. There's plenty of documentation. I think spending time there would be a great investment for your entire PSVR development and your general VR development. And last but not the least, keep in touch with us, be it on DevNet. Don't hesitate to open a private support ticket if you want, or post on forums. Also, for any other issues, get in touch with your account manager. They can be a great source of information and help. All right, and that's all I have for today. All right, any questions? Well, if you can think of any other questions later on, you can always email me. All right.
So how does PSN handle developer updates, like if we have to patch something, or can we add continuous content to a title?
Yeah, absolutely.
Okay.
Absolutely. Okay.
Hey, hi.
Yeah,
Are you funding VR project? Do you have a fund for that, like Facebook or?
Well, I'm not sure, but I think you should be able to, email the link in the registration site. There should be a help. So
Okay, cool.
just mail them, and I'm sure they will have all the information for you.
Thanks.
Thanks. All right, if you have no questions, let's wrap it up. Thank you so much.